So the problem we're going to discuss today is to set up an integral for the first problem. Set up an integral for the surface area. Let's call it surface area. Area of the surface. This is generated by rotating the curve about the y-axis. Now let me just simply write down the equation of the curve. Okay, this is about the y-axis. You have to draw the graph first. Okay, this is a part of the solution. You cannot just write on the formula without in the graph. Okay. So this is first of all, you draw the curve in two-dimensional space. Okay. Then when you rotate the curve in three-dimensional space. Okay, not in high dimension, three-dimensional space. So y equals 1 minus x squared is parabola opens downward. Okay, x is between 0 and 1. So that's a curve. This is original curve you use, right? So you're going to rotate about the y-axis. So this is a picture you're going to get. Okay. So you get surface. How do we set up an integral for the surface area? Okay. Step 1. You write down the formula for the area of surface, which is 2 pi r ds. Okay. This actually is a single integral. Okay. S is the arc length of the curve you use. Okay. And the ds, you have to find a way to find it. You know, this is arc length, right? So S, yeah. So ds is actually a tiny bit on this arc length. So first of all, you figure out what is r. R is a radius. So you are not going to use ds to evaluate this integral. You are going to use another parameter for the integral. Okay, you can consider it like a substitution. Okay, so x, yeah, pick up a point on the original curve. You have two variables, x and y, but they're not independent, they're related to each other. So y is going to be 1 minus x squared, x is going to be a square 1 minus y. They're related. So you can set the one variable as a free variable, then other variable depends on the free variable. Then you can parameterize this curve using x variable or use a y variable. So in other words, if you use x variable, then the arc length s depends on x. But arc length also depends on the y coordinate, right? When changing. So actually, we're going to use a substitution for this function. So what is r? R is going to be x here, clear, right? For that point. So it depends on which variable you're going to use. You're going to use the x variable, then this is enough. If you use the y variable, this is square root of 1 minus y, okay? So you have two choices to replace the ds, okay? So ds is going to be 1 plus dy over dx squared dx, or dx over dy squared plus 1 dy, okay? We choose one of the variables, okay? So that's it. So what I'm doing here is, originally this is a integral with respect to the arc length of the curve you use to generate the surface. Okay, so this thing, but this is harder to evaluate. The formula looks very simple, but it's harder to evaluate. Okay, why it's harder? It's harder to find the relationship between r and s. You know, if you want to evaluate this integral, right? So you let s changes, the arc length changes, then the radius changes too. But how do you find the relation between radius and the arc length? In some cases you can, such as like a cone, right? But here it's harder to find out. okay? Because it's harder to find. Yeah, it's hard. It's almost impossible. So what they'll do is we're going to use another parameter for the curve, is x or y. Okay, you can use x as a parameter for the curve, or use y as a parameter for the curve. But r cannot be arbitrary. R must be equal to x. Okay, the first coordinate of the point. But if you want to use the y variable, then you change it to square root of 1 minus y. Square root of 1 minus y. Okay. So this is the idea. Right. So I'm going to set up two integrals for the same surface area. The first we have to find the first integral will be integral with respect to x. Okay, x is start from 1, 0 and 1. 2 pi using x, okay, dx. So here I is going to be just x, and 1 plus the derivative y with respect to x is negative 2x squared. Okay. This is important. You already get 80% of the credits if you do that. Draw the picture, and you pick a point on the curve and mark the radius. Okay, and then you write down what is r in terms of x or y. Okay. Then also you have to write down ds. Then depends on which variable which parameter you're going to choose. If you choose the x variable and use the first one, if you choose y variable, use the second one. Then you put everything into the formula, right? You get the integral, and guarantee you get the surface area. Or if you want to use the y variable, y is also start from 0 to 1, right? Yeah, so it's from 0 to 1, and it's 2 pi. R in this case is going to be square 1 minus 1. Okay, and the derivative of x with respect to y is going to be, I think it's going to be negative twice of this. Okay, when you differentiate, yes, when you differentiate, you get this n plus 1. It looks like a complicated, but does not mean. Okay, after simplifying, it's simpler actually. Okay, let's look at 2 pi. What you get here is going to be a quarter. Yeah, let's see. Okay, here's a 4, 1 minus y, right? And this is 1 plus 4, 1 minus y, right, dy. And this 2 cancel out. Okay, this 2 cancel out. And this 2 cancel out. Okay? So you get pi 1 plus, it's a 5 minus 4y dy. Okay, this is a nice integral. All you have to do is to use a substitution to evaluate this integral. Okay, so you let u to be 5 minus 4y, du equals negative 4 dy. Okay, and that is going to be when y equals 0, u is 5. When y equals 1, u is 1. And here u to the 1/2, negative a quarter du. Okay. Since this is a negative sign, so I can change the order. It's quarter from 1 to 5, and the pi u to the 1/2 du. All right, then you find the antiderivative. You're going to get a positive number, okay? So you're going to get pi over 4 here, antiderivative 2 over 3, u to the 3 over 2, and evaluate that to end point. Okay, so you're going to get pi over 6. 5 to the 3 over 2 minus 1. Right? Let me check if this is the answer I got here. Yes. Okay. So I will ask you to do the same, we have two integrals, right? So the same problem, but the notation is about the x-axis. It's a y minus 1 minus x squared. And load, it could be quite different surface. Okay. Set up two integrals for the area of the surface. Okay, so this is the surface I already draw for you. It's a rotation is about the x-axis. So again, you know, this curve can be described in two different ways, right? Yeah. You take a point, has coordinates x and y. You have to write down, you have to draw the r, right? That's r. So r is going to be the y this time. Y is also going to be 1 minus x squared. Okay? So that curve is parameterized by the arc length s, but this is not going to be very useful to evaluate the integral because surface area is going to 2 pi r ds. I still not able to find a relationship between r and s. And so I have to change it to the x variable, change it to the y variable, or change it to the y variable. So the ds is still same. These two pictures, this one and above one, ds is still identical. It's the same ds. You will see that because the same curve. Okay, the only difference between those two pictures here, the one on the top, the one on the bottom, is the radius r. Okay, so ds is still the same. So we already did it, right? ds is going to be 1 plus dy over dx square. Okay, so we already know that it's going to be 1 plus, it's negative 2x squared dx, right? Or it's going to be dx over dy squared plus 1 dy. And after simplifying, I think this is what I got. Okay. So I can simplify a little bit. So I take this out. I can put it in the denominator. Here's a 5 minus 4y. Okay. I just write down the answer. We already did that from above problems. Okay. I think it's 5 minus 4y. Yes. Okay. So we have two versions of two versions. Yes. So that now the surface area, if you use x variable from 0 to 1, 2 pi, everything should be expressed in terms of x. Then r is going to be 1 minus x squared. Okay, that's the integral. Or it is the integral for y and the ds. ds is square of 5 minus 4y, 2 square minus 1y, dy. And I don't think we're able to evaluate this integral. The second way, especially, it's impossible, maybe, right? It's not that impossible, but it's hard. Okay, it's complicated. Okay, it is complicated. Okay, I think the first one, maybe we're able to evaluate integral for the first thing. Okay, but there's x there, x squared. So I'm not going to complete this. I just set up two integrals. You can even use a software to evaluate. You get the same answer. Okay, different integrals. It's harder to tell they're the same. Okay, if I did not tell you this come from the section about surface area, and it's hard to tell that you get the same answer from these two different integrals. Okay, but that represents, yeah, the same surface area. Yeah, amazing, right? So those two are the same. All right. Section 8.3. We will focus on center of mass. Right? How do we get a formula for the center of mass? Okay. We have to learn this calculus idea to get the formula. Then I run the formula now. Okay. So suppose I have a bunch of points. If it's one-dimensional case. Okay. So first of all, let's look at the discrete data. Okay. So along the x-axis, right? Suppose you have a bunch of points as coordinates x1, x2, x3, xn, and at each point there are some mass here, right? Mass here. So it's 4, and here's the mn. So the total mass is them together. Okay. Then I just look at the one-dimensional case. Okay. Then the center of mass is going to be the coordinates. So this is what we figured out. Okay, so depends on how heavy of that point it is. And that's a total. Right. So the center, right, it's going to be m over sigma n from 1 and xi mi. Right. So it's like kind of like a weighted sum of the x coordinates of those points. Right. So and then you get how do you this is a one-dimensional case. If you are given the density function of if you are given the density function, and how do we if you're given density function, how do you find the center of the mass? Okay, if you find the density function, then use a continuous function, right? So if the same here, but this is a piece of interval, and you have a dx is a density function, right? And then we're trying to record it, So it's not evenly distributed, the mass. Okay. In this case, you divide this into many subintervals. Okay. So you can assume here's x0, x1, and here's xn. Okay. So delta x is going to be b minus a of n. This is point A. That's point B. So you divide this whole piece into many slides, many pieces. For each one, you can consider as 1 point. Okay, so the weight of that piece, okay, the weight of that piece is going to be density function. Okay, so let's call it mi. Okay, so mi is the mass of the ice piece. Species, as a species. Okay, so this is about the density function times delta x. Okay, right. So the total mass is going to be the sum of mi, I from 1 to n. You add them together. If you add them together, it's going to be Now, if you take the limit, you get integral from a to b of this function. Right. So that gives you the formula for the total mass. I just recall how do we do that in dimension 1 case. Then, if you want to find the center of mass, how do you do that? You just find you have n pieces here. So x bar should be about equal to the ratio of this. Okay. Right? Then this is going to be nothing but xi rho xi delta x. So after you take the limit, and you will get formula from a to b x rho of x dx, and the denominator is also the integral of this density function. So this is a formula in dimension 1 case. Now we are going to use a similar idea. We are able to find. We can find the center mass if with a density. Right. So this is a two-dimensional case. Two-dimensional case. The formula is given in the book. They are considered slightly more general case. I think in mass 261 we can talk about more general regions. So so now we consider a region in the XY plane. Okay, but this region is described by two functions. Right? It's a y equals f of x and y equals g of x. Okay. And here the density function is constant. Okay, use the density function. We make the simple. The density function is constant, just 1. Okay, just constant. Okay. Otherwise, will be much harder to involve double integrals. Okay, so I want to find out the center of this. Okay, find the center of mass. Okay, so the idea is the second formula is a little bit more complicated. It's harder to understand. So let me write on the formula first. Okay, in the book, you are given the following formula. First of all, A is the mass. Okay, so this is going to be the integral from A to B, and f of x minus g of x and dx. Okay, and the x bar is going to be A. The numerator is going to be just the difference, the integral of x and the difference of these two. X times the difference of these two functions. And the y bar is going to be A and AB. This will be half of f of x squared minus g of x squared. Yeah. It's a little bit harder to derive it. Okay, maybe I can explain to you how do I get x bar and how to get x, how to get A. right now, the density function for the region is constant. Okay, just assume equal to 1. Okay, let me show you how do we get this x bar. The idea is I project this whole piece onto the x-axis. Okay, so at every point, okay, the density function actually is going to be the difference of these two functions, the length. Okay, so that if the whole piece, okay, whole domain collapse to the x or and collapse to the projected to the collapse or project doesn't matter, to the interval on the x-axis. So the total mass can be viewed as the mass of this interval with the density function. Okay. Okay. So that is just nothing but the integral of the difference of these two functions. If x bar y bar is the center of this domain, then the projection of the center on the x-axis will be x bar. X bar should be the center of mass of this interval with the density function. So that's the reason it's going to be a of the integral from a to b x and rho of x dx. Okay? Yeah. So that gives you f of x minus j. So how do we, okay, maybe we are going to test you about this section. I just ask you to find the, but make sure memorize those formulas if you don't understand it, okay? And find the center of mass, or find the mass or the area of the region, between those two curves, okay? So just find evaluate integrals, right? In the book, they're trying to show you how to derive these formulas. Especially the y bar one is more complicated than the x. Okay. The reason is, yeah, we have found different ways to figure out the y bar. Okay, x bar is just you collapse the whole domain onto the x-axis. You get an interval, but then the length of each cross section gives you the density function at that point. Okay, so let's take a look at some problems from the book. We're going to find the center of the semicircle. Semicircular center of radius r. All right. Right, so let's draw the picture here. So this is circle with radius r. Okay. And when you look at the picture, okay, how do you solve the problem? Well, the center must be the y-axis. Okay. So clearly by the symmetry, you don't need to waste time to do that. Okay. So A is going to be the area as the integral of this function from negative r to positive r. It's r squared minus x squared dx, because this is a graph of this function. Okay. And we already know that it's going to be half of pi. Why? Because this is the area of right, this is the area of the semicircle, so it's divided by 2. Then you write down the two formulas. Okay, it's integral from negative to positive 1, and that is going to be the difference of this function. Okay, and the y bar is going to be a here is negative to positive 1, and half of this function square. Okay, half of the square of the function. Okay. I think we don't need to do the first one. It must be 0 by the symmetry. And this is also an other function. X times square r squared minus x squared is the other function. Okay, so that's why it's integral over negative r to positive r. It's going to be 0, cancel out. Negative part, positive part are similar, so they cancel out. The only, yeah, we just need to find the y bar. Okay, so I leave a here, and after squared, you get r squared minus x squared dx. Okay. Then you have this r squared x minus 1/3 x cubed. All right, so evaluate this integral, what I'm going to get. R squared r minus 1/3 r cubed minus r squared minus negative, okay, times negative r. And here is negative r cubed. So this actually is the same but different by sign, so it's double it. So I get 2 canceled out. So will be 2/3 r cubed. Okay. What is my a here? A is already half pi of r squared. Half pi r squared, and here 2/3 r cubed. And clearly, you will get 4/3 pi r. Okay. So this is the location. This gives the location of the center of mass. Center of mass, right? So this is a simple problem, so computation does not involve too much work here, especially the area. We find the area of the semicircle by using the classical formula. Okay. My next problem is I want to find out the descent of a mass of the foreign region. The region is bounded by the curves y equals sine x. X is between 0 and pi. Y equals 0. Okay. So let's draw the picture first. This is sine curve, right? And sine curve is symmetric in some sense. So the center must be somewhere here, x bar, y bar. So clearly x bar is going to be half pi. I don't even waste time to do that. Simple observation. Okay. The only part we needed to do here, this is a y equals sine x, right? So you write down the formula for y bar. Y bar is going to be half of the integral from 0 to pi, and the the function sine x squared dx, okay? And then the bottom is the area, A. We already know the area, the integral of sine x. This is going to be 2. Okay. So it's going to be cosine x negative from 0 to pi, and which is going to be 1 minus negative 1, which is going to be 2. Okay? So the area of this region is going to be 2. All you have to do is to evaluate the integral on the top. Right? So let's evaluate this integral. Okay. I'm going to find this is I think it's going to be sine squared. It's going to be 1 minus cosine 2x dx. Okay. So the entire derivative, the first one is half of x. The next one is minus 1/4 sine 2x. Okay. Right now, plug pi for x. I think you just get half pi. All right, so now y bar is going to be integral, half of the integral is half pi over 2 and divided by 2. Okay. So which is going to be pi over 8. Right? It's reasonable. When you get a number, you have to check whether it's reasonable or not. So this is a pi. The highest point is 1, right? And the most part, when half is here, I think the center should be below that point, right? Because the more areas below this line, so this should be equal to negative. This should be equal to 1 negative 1/2, and now it's clear. Pi is less than 4. Okay, that works. So double check your work, at the end. Okay, next problem. Sketch the region bounded by the following curves. Y equals x cubed. Oops. This is a wheel. I think the current is different from another class. Okay, I do not have such experience. Like, when right on the screen, there's one line shows. Yeah, the screen is very sensitive to color. So something is wrong with it. X plus y equals 2 and y equals 0. All right. So then find the centroid. Right, that means x bar and the y bar. Right, let's finish this problem. How do this do this problem? You have to sketch the graph first. All right, fine, yeah, then, so step one, draw the graph. I believe that in the future, there's only need one professor for the whole country teaching calculus course. Not me, but some find a better way, okay? Why? Because first of all, you see, you just sit here, right? You know, there's no interaction, right? They never ask questions most of the time. So just need someone. You know, you can machine, it's not necessarily a professor, a real person, right? You know, right now the technology is very good. If you write an article, just let the computer read it and broadcast it. So you sometimes you don't hear the difference. Okay, I already watched YouTube videos. It's not a real person, right? And the calculus is a very standard textbook. It's not like the new, you know, a graduate course is different. You know, the most recent research. That some real person have to do that. But this is not necessary. Even middle school, high school, math. Okay. So in the United States, not many, some elementary school, middle schools, their teachers don't teach mathematics. Why? They just turn on the computer and let students sit there and watch it. Okay, because like a Khan Academy, Concept Academy, I call it. Yeah, this is a guy who record all the lectures and post that for free. Right? It's better than the teachers in the classroom. Okay, don't trust the, yeah. First of all, this job is not very attractive, okay? That's why you guys want to become engineer, don't want to be high school teachers. You're good in math, but you don't want. That's so, because they're not attractive job. So that was the quality of, you know, this teaching grade in high school, middle school, they're not good, okay? Okay, so that's another option, you know, that can get the videos from the internet, teach the kids. Okay. All right, so find the center and x bar, y bar. Okay, so let's draw the graph. Okay, y equals x cubed. Okay, so this is a x cubed. So y equals 0 is the horizontal x-axis. X plus y equals 2. What is that curve? That curve is the line like that. Okay, it has -1 slope, but just figure out 2 points. 2 points uniquely determined line. So when x equals 0, y equals 2. So this is a point. When y is 0, x equals 2. So that's another point. Just draw the line. All right. So there's the intersection point here. You will see that there's the intersection point. So you have to find out what is the intersection point. Okay. The intersection point is going to be, can we solve it? Right? It's x plus x cubed equals 2, right? I can only, in general, I cannot solve this equation. By guess and try, you can get. Because x can be what, right? 1 plus 1 equals 2. So, yeah. So this is indeed, you can do quickly. In general, you cannot do that. But this particular problem, you can find a solution. Okay? So this is the point. The graph is defined piecewisely. So actually, this is a graph y equals f of x, but this f of x is x cubed if x is between 1 and 0, and 2 minus x if x is greater than 1, less than 2. Okay? It's continuous function, but it's not smooth function. That's okay. So you have to express the region of this. Then the area is going to be integral from 0 to 2 f of x dx. Okay? Then you have to write down the bar. X bar is 1 over a, integral from 0 to 2 x over f of x dx. And the y bar, yeah, before you do the computation, you write down these two formulas you can use. All right, so A, what is A here, right? So let's do step by step. The area is the integral. You have to break into two parts, from 0 to 1, x cubed dx, and from 1 to 2, 2 minus x dx. The entire derivative, and here will be 2x minus half of x squared, and from 1 to 2. Okay? There's no other choice. You have to do that. Separate. That's a quarter plus 2 times 2 minus 1/2 2 squared, and the minus 2 minus 1/2. Yeah, be careful about these numbers. It's 4, and here's minus 2. Minus 2 minus 1/2 is 3 over 2. Okay? So let's continue to combine them. Okay? I'm going to get 2. Fractions. Okay? Fractions. Okay, this is going to be 4 and 6. Okay, finally I got this. Okay. I hope it's right. Okay, so this is the area of that region. Area of that region. I think it's reasonable. This looks like a triangle. Okay, think about this triangle. If this triangle, the height is 1, the base is 2. This you should get an area of 1, but this is smaller than the triangle. Okay, so this is gonna be like that. So this should be smaller than the area of the triangle. The area of the triangle is what? Right now you got 3/4. I think it's reasonable, right? All right, so then you find the x bar. Before you find the x bar, just find the evaluate the integral, okay? It's from 0 to 2 x of fx. And you do the same thing. Integral from 0 to 1, and that'll be x to the 4th power. And from 1 to 2, it's be 2x minus x squared because you multiply that by x. Then evaluate. And here's x squared minus 1/3 x cubed. Evaluate at 3 endpoints. Right. Right, so you get 1/5 plus 2 squared minus 1/3 2 cubed minus 1 minus 1/3. Okay? So we we will get 4 minus 8 over 3 minus 2/3. Let's do this way. 2/3. 8 over 3. Okay? You can get 10 over 3. And combine them, 1/5 minus, oh, that's too bad, right? It's getting more and more complicated. All right, so 10/3 minus 1/5 is equal to 15. 50 minus 3. 50 minus 3 here is 47. And then 4 times 15 will be 60. So 13 of 15. Okay, so x bar is going to be 13/15, then 3/4. Okay, divided. Okay, so we are now able to simplify. This is going to be the number 45 denominator. (52/45), which is slightly larger than 1. And let's go back to check why it's slightly larger than 1. And then look at the picture, right? And you have more area under the straight line than under the curve. Okay, so the center should be somewhere here. Okay, that's why it's slightly larger than 1. This is a 1. It's 2. Okay, makes sense. Okay. The y bar should be less than 1. Definitely less than 1/2. Okay, so let's be patient to calculate this. So integral from 0 to 2, half of, oh, I'm going to run out of battery. Hold on. I forgot to order my battery. I still have to take it out, put it back. This is a special battery. Where I can buy it, you know? Tiny, maybe, tiny. How many A's? 1, 2, 3, 4 A's. 4A battery. It's not very popular. Okay. Okay, I think it still works. Half of f of x squared. Okay, dx. I think the Radio Shack usually have this change. Hopefully that store is not closed. They usually have this kind of battery. All right, so now you still have to, it's a piecewise define. So cube, so x to the 6 dx plus 1/2. And I forgot the function again. I'm not good about memory. Okay, 2x minus, no, 2 minus x. Yeah, 2 minus x. 2 minus x. Then square this time, dx. So the entire derivative of this is 1/7. Okay, and plus 1/2. And how do I find the entire derivative of this? I think I'm going to use a substitution first before I do the problem. Okay, the substitution, because otherwise it's a square that's too complicated. So you let u to be 2 minus x. Okay, then du equals negative dx. Then when x equals 1, I get a 1. When x equals 2, I get 0. That's u squared negative du. Okay, so this will be just 1/7. And here I can get a nice integral, just 1/3. Right? Yeah, because 1/3 of u cubed take a difference at the end point. So 1/3. So now I get 1/2 taken out, 21, right? 7, 3 plus 7 is 10, so I divide by 2, this. All right, finally, the y bar is going to be 5 over 21, 3 over 4. Okay, so 5 over 21, 4 over 3. 61. That's 63. So this is clearly this number smaller than 1/2, smaller than 1/3. I think it's reasonable. Okay. So this section is done. I'm not going to continue to waste too much time, but I still want to go back to review the problems from last section. I wanted to set up the integral for the surface, for the area of surface. Okay. Yeah, just do one more problem. Given the curve rotated by y-axis, set up integral for this is a problem. Yes, this is about rotation, is about y-axis. Problem number this is number 16. Okay. Y is between 0 and 1. This is a rotating about the y-axis. Okay. And we want to set up an integral for the surface. Okay. For the area of the surface. Well, you say, well, this is a strange equation. How can I sketch this graph, right? Yeah, it's not easy to sketch the graph. That's true. But you should see that you should see that when y is between 0 and 1, what is the x value? You see, when y equals 0, I think x is going to be 1, right? A plus minus 1, right? X is plus minus 1. Yes or no, right? Because when y equals 0, x 2/3 equals 1. For what kind of x? You get x, right? By definition, this will be x to the 1/3 square equals 1. Yeah, this is a review of a algebra, okay? That's the definition of this. So x to the 1/3 is plus minus 1. X is going to be plus minus 1. Okay, so you get 2 points when y equals 0. So y is between 0 and 1. So let's assume y equals 1. When y equals 1, x is going to be 0. So I believe that the graph looks like that. Okay? If you allow y is negative, then it would be like this. So this is like this symbol. Okay. So we're talking about the surface area of the surface generated by rotating this curve around the y-axis. Okay. So this is so that you don't need to use it as a piece. It's a symmetric. Okay. So actually just need one piece from here to here. So this is the piece x is greater than between 0 and 1. So be careful about this. And you can describe this curve in 2 different ways. Yeah, we just only consider that piece. Okay, this piece, this curve is used to generate a surface. Now, what is the best way to solve this problem? I'm going to Yeah, first of all, you write on the formula, right? Area equals 2 pi r ds. This is the universe formula. Okay. And r is going to be x. Here's x and y. So r is going to be x. Okay. So ds is going to be 1 plus dy over dx. That's traditional way to do, right? Or and dx over dy square plus 1 dy. Now, if you want to set up the integral, all you have to do is, I don't know which one we use. I think we should use the x variable because I is already using x, right? So it's better to use x variable. Yeah. But I still have to solve for y. Y 2/3 equals 1 minus x to the 2/3. Okay? And how do I solve it? Y is going to be positive, right? So this is actually, it is going to be like that. It's a 3 over 2. Okay, turn this upside down. Okay. So y is positive between 0 and 1, x. And here, x is between 0 and 1. Okay. So differentiate. When differentiate, you get the 1/2. It's negative 2/3 x to the negative 1/3 because 2/3 minus 1 is negative 1/3. And I hope we can simplify it. If you don't want to simplify it, then this is a 2 canceled out. Okay. If you don't want to simplify it, this is surface area. X is from 0 to 1, 2 pi x square root of 1 plus this whole thing square. This whole thing square will be x to the negative 2/3, 1 minus x to the 2/3 square, so dx. Not too bad. Looks. I think I can simplify, okay? And then you multiply this out, and the second term is 1. So 1 canceled out, great. So 1 canceled out, I will get square root of x to the 2/3, negative 2/3. So then 2 is gone, right? Then x to the negative 1/3. Yeah. The key point is to use which variable. You have to decide which variable you're going to use. X to 2/3. Then you find the antiderivative. Right? That is going to be 6 pi over 5. And that's it. Okay. So I did not know the integral be simplified to this way. Okay, I thought they just set up an integral, but it's easy to evaluate. That's the reason I did it. So let's go back to the problem. Set up the integral for this, right? You draw the graph. You find out you just need the one piece, okay, one piece of the curve to rotate around the y-axis, okay? And then how can I draw the graph? I have to choose 2 endpoints, okay? Then you write the formula for the 2 pi for the area, but you write down what is radius r, right? R is going to be x. Then you have to choose one variable, either x variable or y variable, to use that as a parameter. Okay. Then you get this formula. Okay. Don't be scared. Just solve for y and then differentiate, and you put it into the formula and simplify. And indeed, you can simplify. Right. Then you get this. But there's possibly another way to parameter this curve. Okay, here's the 1, right? And the x to the 2/3 plus y to the 2/3 equals 1. Remember this function, right? If it's 2/3, 2/3. And I think maybe you can parameter it in the form x equals cosine cube t, y equals sine cube t, why? Because when you take 2/3, you get square. Square plus square equals 1, right? Yes, no? Yeah. X, then when this satisfies the equation, okay? So if doing this way, then what you can get is ds is going to be dx over dt square plus dy over dt square and dt. So when you square it, when you differentiate, it's going to be 3 negative cosine square t plus sine t. And here 3 sine square t and cosine t and square square. I'm not sure it's getting simpler, but this is what you get. Okay, but you can simplify. I think so. The reason is you can take sine t, cosine t out. You can take 3 out, and you can take cosine t, sine t out. Okay, then you only have a cosine square t plus sine square t inside. Okay, so you get cosine t, sine t, and dt. Okay, because this is going to be 1. All right, so my surface area is going to integrate from 0 to 2 pi, 2 pi r, I is x, right? I is x, I is x, because this is r. So it's going to be cosine cube t. And the ds is going to be 3 cosine t, sine t dt. Okay? And I'm going to put 6 pi out to the 4th power sine t dt. Then you see, oh, we can use a substitution again. You let u to be cosine t. Okay, du equals negative sine t dt. So when t equals 0, u is 1. When t equals power 2, 0. And here is going to be u to the 4th power, and that's negative du. Okay? And the antiderivative of this function is going to be 1/5 u to the 5th. So the answer is 6 pi over 5. You gotta get right answer now. 6 pi over 5. I forgot already. 6 pi over 5. Oh. Okay. So no matter which way you do, as long as the computation is correct and you get to the same answer, that's magical mathematics. Mathematics is different from biology. Okay?